Hello everybody and welcome back to another installment from our series Straight from the Horse's Mouth. Access to resources has been a big issue for the EU for the past decade. The current hot topic, producing raw materials sustainably and in massive quantities needed to generate low carbon power and support electric transport to meet the EU's 2050 net zero target. Circular economy principles play a huge role in minimising market disruptions, price volatility and risk. Here's a sneak preview.
So the EU now has an action plan on critical raw materials, which essentially is four streams. And this was the main focus of the Raw Materials Week this year, which was around building resilient supply chains, so particularly through international partnerships. So in 2011, as I said, there was the rare earth crisis with the ban on exports of rare earths from China. That gave rise to this whole realization that we're actually really heavily import dependent. Also, we're experiencing a global decrease in ore grades. So it's taking us more time and effort and money to extract materials from the ground that we need. And unsurprisingly, China is producing the vast majority of the materials. They have pretty much the entire periodic table being produced in China. Taking all of these metrics and distilling them and understanding how they interact, combining that with expert knowledge, particularly around substitutability of materials, which is one of the strategies to solve these risks, is part of what the European Commission does through its partners to compile these lists of critical materials.
Whatever the EU is driving really does actually have a global impact and certainly impact on what we do here down under.
Jim Goddin, a member of the International Roundtable on Materials Criticality, shares how industry leaders are employing circular economy principles and innovative technologies discussed during November's Raw Materials Week. With that, let's get started.
Good morning, everyone. Let's get started. Welcome to today's webinar on the role of circular economy and raw materials. And we've got our very own Jim Goddin presenting to us today, our head of circular economy here at thinkstep-anz. He's currently not quite based here, but that means he could attend a couple of really interesting meetings and sessions over the last few weeks, which he will tell us all about. So it's a circular economy and critical materials, the European perspective. And why that is relevant for us down here, Jim will share that with us. Over to you, Jim.
Yeah, this session is about circular economy and critical materials, which are two of my favorite subjects. I've been working at the intersection of these two, as well as hazardous materials and eco-design for the last decade, slightly more than a decade now. Particularly in the realm of materials. I'm a material scientist and engineer by background, now head of circular economy at thinkstep-anz. So what I'm going to focus on in this session is the outcomes of two sessions that have happened in the last month. Raw Materials Week is an annual event that takes place in Brussels usually, and has been running since about 2011, shortly after the rare earth crisis of 2009. The International Roundtable is run as a side event to that. It's funded by the EIP on raw materials, a European program, and focuses on bringing industry and academia together, particularly to explore implementation of circular strategies and management of critical materials. And it's an international panel of experts covering the US, Canada, Japan, Korea, you name it, everybody's there. And I have the pleasure of being part of that panel from the UK's perspective. So what do we mean by critical materials? I'm really going to highlight that through this slide. So in 2011, as I said, there was the rare earth crisis with the ban on exports of rare earths from China. That gave rise to this whole realization that we're actually really heavily import dependent. And this plot on the left, which is the 2011 list of critical materials that was developed by the European Commission and their partners, which really plots economic importance on the horizontal axis against supply risk on the vertical. And that list has been maintained and expanded over the years. We're now on the 4th implementation of that was released in 2020. Now, I'm aware the figures are very small. So here's a sort of distillation of those two figures. At the top, you can see the 14 elements that were included in the 2011 list. I'm aware there are 15 elements on this, but that's because light rare earths and heavy rare earths were grouped together as one, and then split apart in the 2020 list. And you can see from the arrows at the top there, whether those risks have been perceived to have increased or decreased. The majority of them have increased in risk between 2011 and 2020. And we've had another 15 elements that have been added to that list that are now perceived as critical to European industry. So these are elements that have an elevated risk of supply disruption and are also considered of crucial importance to European economic output through a variety of different sectors, which we'll come onto in a minute. Now, the underlying causes, there are many. I think principally beneath them is the expansion of the middle classes, who are all aspiring to greater levels of consumption of materials. There is a huge increase in demand for materials globally. Also, we're experiencing a global decrease in ore grades. So it's taking us more time and effort and money to extract materials from the ground that we need. So those two combined are leading to increases in volatility and monopolistic behavior, shall we say, in terms of trying to retain the value of those materials for domestic output. And we can see the level of monopoly that's emerged. So on the left here, we're looking at all of the elements that are on the right here in terms of total global production. And of course, this isn't representative of the supply risk of individual elements, but it gives you a feel for where the concentration is supplied. And unsurprisingly, China is producing the vast majority of the materials. They have pretty much the entire periodic table being produced in China. And we're also seeing areas like Russia and parts of South America dominating, and of course Australia, who are a big mining nation themselves. So we can see that there is a monopolistic supply, or at least concentration of supply. You can also see from a European perspective that very little of that supply is in Europe anymore. Europe has divested itself of mining and is now struggling to get that mining activity back, which we'll again discuss in a minute. It's also a question of the risks that are at play in those different regions, so whether it's the environmental performance of the country that are producing those materials. That's increasingly of importance to the EU, who have realised that actually, if we're going to decarbonise our economy, we can't do that at the expense of sourcing materials from countries which are producing those materials unsustainably. It is a difficult challenge to do, to both source those materials sustainably and to decarbonise, but that's what we have to do, unfortunately. It's also a question of geopolitical risk. This is one of the main ones. The key indicator there is the World Bank Governance Index, which tends to be used in combination with material production data. And you can see where those principal risks lie. A lot of Africa is included as being particularly geopolitically unstable. A lot of the Middle East, India, Indonesia. So these are areas that are of concern, that are perceived as being at an elevated risk of having supply disruptions to the materials they produce, and are therefore of concern to the EU. Those risk metrics are used in combination, and interpreting them is a complicated process. So I thought I'd put this slide up on screen just to illustrate. So if we look at monopoly of supply for magnesium and lithium on the left-hand side, they're both heavily monopolistic. They've increased from relatively low monopoly, about 2000 on the Herfindahl-Hirschman index, which is a measure of concentration of supply, up to around 6,000 or 7,000 over the similar sort of time frame. So you would think that those were both at risk, but where those materials are sourced from is also very important. So if we combine the Herfindahl-Hirschman index with the World Bank Governance Index, it gives us a very clear differentiation between those, between lithium that is produced in Australia and Chile, which are perceived as geopolitically stable, and magnesium, which is produced primarily in China now, which is considered as geopolitically risky according to the World Bank Governance Index. So taking all of these metrics and distilling them and understanding how they interact, combining that with expert knowledge, particularly around substitutability of materials, which is one of the strategies to solve these risks, is part of what the European Commission does through its partners to compile these lists of critical materials. And of course, these lists will vary from the EU to the US to Japan. They all have their own lists based on the industries that are important and the materials that they use there. And now, why is this all important? I've mentioned some of the industries and I've mentioned decarbonisation. If we look at this image from the critical raw material strategy for the EU, we can see how the high risk materials, particularly the light rare earths and heavy rare earths, magnesium, niobium, germanium, borate, scandium, how they feed through a variety of industries, including batteries and fuel cells, wind and traction motors, robotics, drones, 3D printing, through into key areas such as renewables, e-mobility, and particularly defence and space, where the term critical materials is used less and it's more termed strategic materials, because those are the materials that we absolutely cannot do without from a defence perspective. But the heavy use of rare earths, particularly for magnets, for gearless wind turbines and for electric vehicles, the use of lithium, which is becoming increasingly of concern. These are the sort of things we're trying to manage and come up with a strategy to decouple our use of those materials from the risks that go along with them. So the EU now has an action plan on critical raw materials, which essentially is four streams. And this was the main focus of the Raw Materials Week this year, which was around building resilient supply chains. So particularly through international partnerships, Europe doesn't have all the materials it needs. It can't mine them all domestically, particularly not at the scale that it needs. And because of that, there's a strong focus on trade agreements. So how does the European Union ensure that it gets access to materials that are sourced offshore through the agreement of trade negotiations with countries like Australia and Chile and China? How do they ensure that those agreements ensure that they have access to the materials they need? Interestingly, in the session, there were a number of mentions of export controls, particularly for end-of-life components. So batteries that have come to the end of their life, or electric motors that have been used and need to be recycled. At the moment, a lot of those materials are exported out of the EU to be reprocessed. The EU then buys the finished products back in at a higher cost. The EU is looking to break that cycle by retaining those materials and doing the recycling themselves, and thereby building up their own reserves of secondary raw materials. There's a focus on EU production, and I mentioned secondary raw materials as part of that. But that includes things like sustainable financing, so financing the sustainable production of materials within the EU and outside, and also on skills and jobs. There are a lot of coal mining jobs that are due to be phased out, and the EU is very keen to refocus those jobs onto mining the materials that are needed for a green economy. Diversifying sourcing, of course, and again, as I mentioned earlier on, the EU is very keen to apply sustainable sourcing criteria to the raw materials that come in to fund that and support that green transition. And there will be a strong focus on how those materials are produced, not just where they're produced. And that includes life cycle analysis and ethical sourcing. The whole gamut, along with digital passports for things like batteries as well. And finally, circularity. So I mentioned secondary raw materials and extracting value from those, and the circular economy more generally. And that's kind of the second part of what we're discussing today. And it ties in with the European Raw Materials Alliance, which is a European program which includes hundreds of advanced technology companies and manufacturing companies, miners, who have an interest in building a robust, de-risked economy for Europe. So if we look at the circular economy, where the link is, this diagram was included in the original paper on circular economy. And it highlights how we've had a long-term decline in commodity prices over the previous 100 years, and that's been completely wiped out in the first decade of this century by the growth of the middle classes and the decreasing ore grades, amongst other things. And this was the impetus for the circular economy, which is now valued as a $4.5 trillion opportunity. And the focus of the circular economy is really to decouple the growth of our economy from consumption. So to break that linkage between consuming materials and being able to generate revenue. And it does that primarily by designing out waste and pollution, so ensuring that we can retain products and keep them in use, that they are reused, remanufactured and recycled, preferably indefinitely, and to use that to regenerate natural systems by sourcing biological materials, for example, sustainably and regeneratively. It also includes decoupling from renewable energy, decoupling from fossil fuels, and moving to renewable energy. Burning fossil fuels obviously isn't circular in itself because it's a very linear flow of materials. We're taking things out of the ground, we're burning them, and they disappear, never to be seen or used again. It's also a very good link with the critical materials space because, as we're seeing in Europe at the moment, there is also an energy dependence of Europe on gas supplies from Russia, for example, and there is an increasing awareness of that sensitivity and our access to energy. So there is a huge overlap between the objectives of what a circular economy is trying to deliver and what we're trying to de-risk from in terms of critical materials. So the IRTC, which is the International Roundtable on Materials Criticality, as I said, included a number of industrial partners who presented their strategies and what they've been doing to manage their critical materials risks. And I'm going to present a few of those here. Hitachi was one of the first ones to present. Their focus was on their sustainability strategy, which they've had for about 5 years. And that's enabled them to divert 500 tons of used equipment from landfill, including 20,000 hard drives, which contain rare earth permanent magnets. They're now recovering about 10% of those magnets. And whilst that sustainability strategy was the starting point for the recovery of these materials, they've actually realized over those 5 years that the whole model is economically viable. And now it's the economics of the model that's driving this process and the expansion of this plan. So recovering used products, disassembling those products. With Hitachi, they're increasingly using robotized disassembly because it was taking quite a long time to do manually. And then the reuse and recycling of materials in a closed loop within their business is a highly circular model that's enabling them to reduce their dependency on primary rare earths for their future products. We heard from Royce, not the motor company, the aerospace company, who are now vertically integrating with their suppliers of materials, particularly around capturing scrap from the manufacturing process. The aerospace industry is not very resource efficient when it comes to manufacturing. They generate a huge amount of scrap, and they have agreements in place to provide that scrap back to their suppliers and to exchange that for new material and to get a discount on that new material as a result. They're also employing something that's called the power by the hour model, which is held up by the circular economy as a prime example of how a service-based model should work. So they're selling their products, their engines at cost, essentially, and then have a service-based model where they charge the customer by the number of active hours the engine is delivering. That obviously de-risks it for the customer in terms of reducing their costs. If they don't use the engine, they don't pay for it. But it also drives performance and reliability improvements at Rolls-Royce because they're incentivized to keep their engines running all of the time. and for as long as possible. So that's driven a lot of the technology enhancements that Rolls-Royce have seen over the last decades. I think they started operating this in the 60s. And finally, batteries and PV, so photovoltaics. With batteries, we heard from three innovative companies who are all approaching batteries in a very similar way. They're putting reuse before recycling, so having a cascading model where new batteries become used as secondary batteries in applications in things like tuk-tuks or city mobility scooters, and then move into static applications where the residual power can still be used, even though the weight to power ratio is no longer suitable for mobility. A lot of them are looking at using recycled lithium, and they're claiming a 70% reduction in CO2 from recycled lithium over primary lithium, which again is an environmental advantage. A number of them are also stating the standardization challenge. There are a lot of batteries being produced in very inconsistent ways. They're being packaged in different ways. So getting those materials back at the end of life is particularly difficult. And there's an enthusiasm there to see a more standardized approach emerge. On PV, the main reason, the main challenge that was raised was this design life versus design for recycling. So PVs, solar photovoltaics are good typically for about 30 years design life, and they're designed for that sort of durability. Incentivizing PV companies to design for recycling is therefore quite difficult because they're dealing with something they're not going to have to do for 30 odd years. So the way First Solar was getting around that was by incorporating the recycling facilities with their manufacturing plant. So they can disassemble materials, their own products in the same factory, feed those materials straight into remanufacturing and bring out new products. And by doing that, they essentially lock in their customers to that process. They were also keen to see non-price criteria included for procurement. So as a way of getting around that design for recycling issue, if you're going for the lowest cost, you're always going to go for the longest durability. Recycling is something that sits out in the distance. They raised the point that it would be great to see more companies that are buying solar having those requirements for recyclability at the end of life of their products as an incentive to drive this sort of change. Otherwise, it's difficult to see how it would happen. So just in conclusion, circular conclusions for critical materials. We have a lot of metrics for criticality. We need to not look so much at the European lists or these countrywide lists, but distill those down to the product level and understand what materials are really important for your products. What can you not do without? What is going to be subject to more price volatility? How much volatility can you bear or pass on to your customers? That's an important question to answer. We need to understand our supply chain risks. The circular economy provides us a lot of focal points for that, whether it's material reutilization, the environmental impact, social fairness of where we're getting our materials from, the material health. I mentioned hazardous substances earlier. That's another source of resource risk, if you like, by removing some of the chemicals that we rely on for manufacture, as well as the economics and regenerative systems. There are a variety of tools to help with that. We have things like the material circularity indicator, we have life cycle assessments, life cycle costing, responsible procurement frameworks. And circularity as a whole illustrates a really robust approach to risk management. It's one of those things that is looked on very favorably by investors as a way of decoupling or demonstrating a decoupling from these types of supply risk. And we're increasingly seeing companies using the circular economy as a way of showing that they are decoupling from those types of supply risk. So that's all I'm going to say today. It's been great speaking to you all. Really looking forward to seeing what your questions are and to answering some of those.
I really like on the last slide, because what I realize is what you've said all around the supply chain risks that we can deal with by looking at circular economy. It really complements with LCA, where we look at the impacts of the products. So I think those two really are very complementary. And you can see here, we've got the cradle to cradle all around it. because the circularity indicator measuring circularity and LCA measure what is done, and cradle to cradle could almost be described as a process to manage it all, which covers all those different aspects of reutilization, environmental, social, material health type topics. So I think that's where they really go well together.
Yeah, I think it's also getting that third-party verification is very valuable. The challenge with dealing with these types of metrics, there are so many ways to get bogged down in the information that's there and all the different trade-offs that exist. Having some form of certification that sits at the end of it that is verified by a third party that looks at the picture holistically and gives a rubber stamp, if you like, that those trade-offs have been managed effectively and that there is a plan in place to continue to improve, I think is really important. That's one of the benefits I think I see from cradle to cradle.
That really is, yeah. Jim, you've mentioned one of the examples was magnesium being one of the critical materials.
Yeah.
How is that relevant for us down here? I mean, where is it used? Why is it such a big topic?
Yeah, so magnesium is a really interesting one. It's come a bit out of field. Although the increase in monopoly of supply of magnesium has been going on for well over 20 years. So China started producing more and more magnesium. I think they now account for something like 87% of the world supply, which is huge. And yeah, magnesium in itself is important as a material for lightweighting of vehicles, and it's used in vehicles and aerospace and all sorts of places. But that wasn't the reason why there was a lot of concern. I mean, magnesium was a hot topic during Raw Materials Week. And the primary reason is that it's used as an additive in aluminium alloys. Mm-hmm. And the European Union has some really good aluminium recycling facilities. But whenever they recycle aluminium, the magnesium, at least some of the magnesium, gets lost. It doesn't get recovered by the recycling process. And so they have to top it up with new magnesium. And they're now entirely import dependent on China. So there was a number of the delegates there said that the situation now was absolutely insane, that they shouldn't be so heavily reliant on a third country that's already shown a willingness to restrict access to the supply of other materials, and they've let themselves get to that position by stepping back from raw material production themselves. Mining is an activity that has a lot of NIMBYism. People don't want it in their backyard, certainly in Europe, and that's a huge uphill struggle that the EU has to try and to show that it can access those resources that it has domestically in a sustainable and responsible way, and by doing that decouple from these import dependents. That's
really interesting. The fact that magnesium is used for aluminium recycling. So we cannot just rely on recycling because we still need other aspects to it.
Exactly.
There is a couple of questions. Brian wants to know, is the material circularity indicator internationally standardized, e.g. by ISO? And there couldn't be a better person to answer that than Jim. So over to you.
Fantastic. Yeah, that's a really I could have written that question myself. So there are lots of circularity metrics out there. So there is a committee. There is an ISO committee TC 323 that is working on an international standard for circularity metrics. I don't think it will be specifying its own metric, but signposting to a number of metrics that are compatible. As part of that committee, I'm part of the UK delegation to ISO TC 323. We did a landscape analysis, and there are 110 different metrics that we discovered for circularity. Of those, about half a dozen are actually in use. A lot of them are academic or have been used by one or two organisations off their own back. There aren't very many that are quantitative rather than qualitative, and it obviously depends on whether you're looking at a product level assessment or a business level or assessing the circularity of a region. The MCI is particularly aimed at product and company level assessments. It is entirely quantitative. So it relies on data. In fact, a lot of the data has a very strong overlap with the data you'd need for LCA. And that is not by accident. That was designed because we knew that data would be available generally anyway. And it is one of the metrics that has been picked up by ISO as being in that half dozen metrics that are likely to be signposted. And I think it has a lot of benefits being written by the Ellen MacArthur Foundation and by a relatively large consortium of industry partners, academics, NGOs. It has a very broad acceptance and adoption, and I would say it's probably one of the leading metrics in that space.
Thank you, Jim. Sophie would like to know what's the difference between MCI and cradle to cradle. I might give that a go. So MCI is really just about the circularity, as Jim has just described, whereas cradle to cradle goes beyond and has 5 criteria. It has how healthy or toxic are materials, how well can they be reutilized. That is where the overlap with the MCI comes in. But it also looks at a company level. Do they have a process in place to look at their carbon and energy strategy, at their water strategy, and also social fairness? So cradle to cradle goes far beyond just the reusability and circular and the narrow sense of circular economy. It takes carbon, water, energy, social fairness into account as well.
With the MCI as well, it was designed not to address a lot of those other metrics because they already exist.
They exist, exactly. Yeah,
exactly.
Beyond this, the EU action plan for raw material supply, what is the next EU step towards the circular economy? I guess there is part of it is already in the Green Deal. We've got a couple of webinars recorded and blogs on the Green Deal. It covers circular economy, but do you have, and we can send a link around that too, but Jim, do you have any further insight beyond that?
Yeah, so I think there are multiple strands to the EU's approach on circular economy. We obviously have the Green Deal, we have the Circular Economy Action Plan. There is a strong focus, I think, in terms of, or at least an increasing focus in the role of trade. There's a recognition that a lot of the products that we need to manage in a circular manner don't start here. They start through the supply chains, and circular procurement is a really big topic. We ran a webinar on that previously, but it is vitally important. So engaging with those international partners, we're seeing an increasing willingness to implement standards and requirements on products that enter Europe in terms of their design for circularity. I think we'll see that continue to expand. That's my opinion, and that will apply to things like the material content, the material types. We're starting to see it in terms of things like packaging, with minimum requirements for recycled content of any packaging that's placed on the market in Europe. Also in the UK, that's coming into force in April next year. A £200 per tonne tax on anything that has less than 30% recycled content, and that I think is going to completely change the market, because recycled materials traditionally are either as expensive or slightly more expensive than virgin, sometimes several times more expensive. But by having those taxes in, I think that will really incentivize the use of those recycled grades. And
that has international implications, of course, because we either export a lot of our goods from Australia and New Zealand to the EU. A lot of businesses here are subsidiaries of those businesses, or the other way around. Businesses here have subsidiaries in the EU. So whatever the EU is driving really does actually have a global impact, and certainly impact on what we do here down under.
Exactly. Yeah, that's one of the things I keep raising at APCO as part of the MPTI working group. So Australia and New Zealand has its own recycling targets, and understanding how those are likely to be impacted by the flow of recycled content to places like the EU, I think is going to be important to understand as well.
We've got one more question. Is there any reference highlighted in policy regulation gap in New Zealand related to transforming towards a circular economy? That requires a very long answer cover. I think we might take that offline. The short answer is possibly there are gaps, but there are really good steps towards addressing some of those topics as well. With that, I'd really like to thank you again, Jim, for reporting back from those European initiatives, because it's really important for us down under to actually understand what's going on. And also, Jim has written it all up in quite a lot of detail, so we'll share that on our website very soon as well. Thanks again, Jim. And if any further questions are coming up, just email them through to us and we will get back to you. With that, if we don't speak to you before, we wish you a safe and very Merry Christmas and a wonderful New Year. Thank you, everyone.
Enjoy the rest of your day.
Thanks. Bye.